Absorption. Absorption is the name of the game from here on, literally out. We've looked at a lot of breakdown. We've looked at digestion, taking the food that we ate. My apologies, let me get that started so I can watch time. We've broken it down physically. We've broken it down chemically. And as we work our way through the intestines, we're going to break it down a little bit more, but the primary focus of the intestines happens to be absorption. So if I just pull this area out so we can focus on this last component, we've got the small intestine that we've just entered into. You can't see it here with the duodenum up about here. And then the ileum ends here. We'll get into those names in a minute. Then we work across the ascending, transverse, descending colon until we end up terminating with the rectum and the anus. And at that point, our lunch has truly become feces. It's gone through a bolus phase and chyme phase, and it's chemically and physically changed all the way through. Small intestine, primarily absorption of nutrients. We've broken everything down. Proteins to amino acids, big carbohydrates to sugars, long DNA strands to nucleotides. That's what's going to happen here. We'll look at how. When it comes to the large intestine, now we're looking at a little bit of absorption, primarily water. So water here, I don't want to say all the important stuff, but everything else essentially here. So let's take a look at these components. The duodenum is typically identified or defined as the first 10 inches. That's very subjective. Might be 9, might be 13, but around 10 inches, somewhere around a foot, just under. The jejunum, and hit the 2 J's in there, the jejunum, about the next 8 feet, same thing. Somewhat subjective, could be a little bit more, a little bit less. And then we terminate with the ileum. And a way to remember that is the very beginning of the large intestine is called the cecum, and the valve that allows us to go from the ileum to the cecum is called the ileocecal valve. So if you can remember the duodenum or the duodenum is the first, and you go, man, what's the last? Oh, ileocecal, the ileum, then that just leaves the jejunum in the middle. Now the changes in function, there are going to be some that are going to occur, but what I want to do is take a look at what all of these things look like in cross-section. If we're talking about absorption, what you already know is absorption is going to be all about surface area. Just like when we emulsified the fat. If we did that emulsification with bile, it gives us more surface area to attack. If we want to absorb in these areas, we need to make sure it has a lot of surface area. So this is essentially what it looks like. Any of the three. If I do a cross section, we have these big bumps that come out. You can see them here. They're called circular folds. That increases surface area. But wait, there's more. If I look at each one of these folds, there are little bumps coming off of them all the way around. If I zoom it up, I end up with these. And each one is called a villi. So we've got millions, hundreds of millions of little tiny villi. If I blow up one villi, we've got the cells lining the outside, we have circulatory system inside, and then we have this green thing. That green thing is called a lacteal. You might think, well, wait a minute, I saw red, green, and blue when we talked about the liver. And yeah, you did. This lacteal is going to empty to the lymphatic system. What we're about to absorb as far as nucleotides and amino acids and fatty acids, these are going to go to different locations. Lacteals are all about absorbing fat. And I'll look at the different forms that fat's going to take once it's been emulsified to get into the lacteals. Circulatory system, everything else. And so here's our little outline. If I look at this on a real microscopic view, here are the cells on the outside. It's epithelial. It's pretty simple epithelial. I think it's a pseudostratified. And down here is one of our lacteals. If I take a bigger picture, a bigger view of this, and I cross-section it, and I look at it for real, not a drawing, it looks like this. So I put this image in here because I think it can help you to understand how much surface area we're actually dealing with as the food that you're moving through your intestines right now is being absorbed. It's not just the circular folds, it's not just the villi, it's these, well, it's just the sheer number of villi. And I think the reason I kind of gaffed there a little bit is I want to point out that this goes even further. If I could take a look at one of these individual cells, I don't know whether you can see that or not. I'll back up to a bigger image. There are individual little extensions coming off. Let me go back up to this. So it's what's called a brush border. So yeah, we've got our circular folds. Yeah, there's a circular fold. We've got our individual villi, and then off of each one of these individual villi, we have brush borders. I have not looked up the formal surface area of the small intestines, but I'm sure it's incredible in absorptive ability. Now, you might wonder, what's the brush border all about? The brush border, I hate to say, is all about chemistry. Let's take a look at some of the things that are secreted in, of course, the duodenum and the jejunum and the ileum from the brush border. And it's what's on the left-hand side. We've got sucrases. We've already done a lot of breakdown from starches to small sugars, but sucrose is a two-sugar, it's a disaccharide. Sucrase now is going to break it into actual glucose molecules. Maltase, lactase, dextranase will break down maltose, lactose, and dextrose. So we even further break down the chemistry of the carbohydrates. So we literally destroy these things. And then of course, enterokinase, that's being secreted because that helps to fire up all of those zymogens that we talked about from the pancreas. Now, when it comes to absorption, let me back up just a little bit. We absorb these simple sugars, simple nucleotides, simple amino acids directly into the circulatory system, and they shoot right back to the rest of the body through the circulatory system. We have the raw materials that we need to build more of ourselves. When it comes to the fats, when it comes to the lipids, they behave differently, so they need a different route in. This is an image, I believe, that I had taken out of your text, or our text, and here's what we've got happening. Up here, we've got the emulsion that we saw with bile of our fats. This is in the lumen, the opening on the inside of the intestine. And once they're emulsified by the bile, they can be pulled in. Now they're pulled in, hey, look at that, there's that brush border. Instead of getting right directly passed into the circulatory system, they run through the Golgi body, not important to know that, but they change their form. And they get surrounded by protein and they become even smaller. And then what we call chylomicrons are going to be dumped directly into the lacteal. So let me walk through this one more time. You eat some fatty food, the bile emulsifies it. We call them micelles, M-I-C-E-L-L-E-S for plural. Micelles are then pulled in, they're converted, and they're secreted as chylomicrons. Those chylomicrons then are absorbed into the lacteal. The lacteal pushes them back to the lymphatic system, and they end up entering in with the circulatory system up around the subclavians. This is the absorption part, at least of that nutrient. Now when we kind of work our way through, there are patches, areas of, well, immune cells. And they're called Peyer's patches. And so they can set up immune responses. And as we move towards the ileum, we get more and more and more of these. And by the time we get to the intersection between the ileum and the cecum, the large intestine and the small intestine, we have lots of them. And I'd ask you why, but I can't. Let me just keep going and I'll try and get back to that. Here's the ileum. This is what we've just gone through. We've talked about the brush borders, the villi. Now we get into the cecum and our ascending colon, our, it's not on here, transverse, and then our descending, and then we end up over here ultimately with the rectum and the anus. Now here's the deal with the Peyer's patches. The closer we get to here, this is loaded with bacteria, and we want to have good bacteria. We want to have probiotics. If they make their way in here, that's a problem. So these Peyer patches get really, really, really frequent when we get to the ileocecal valve, that intersection between the two. The appendix, some people say it has an immune response or an immune function or role. If it does, it's very, very tiny. Now what we're going to see is, at this point, the developing feces working its way up your right side, across your abdomen, and down your left, until we get to this sigmoid colon. Now, how does it do it? Here's how. It's called rhythmic contractions. I'll get back to this in about 10 seconds. When I go all the way back to, this small intestine, this is peristalsis, just like we talked about with the esophagus. So same thing, we've got these rings that are going to be pushing through. We don't see that with this. This is really evolved differently. If you look at it anatomically, it looks different. Not only is it bigger, but just the form of it is different. So what we have are what are called haustra. So each one of these is an individual haustra, and it doesn't move via peristalsis. What we want to do is mix this up. We want to mix the water, we want to mix the fiber, we want to mix the bacteria. So that's where rhythmic contractions come in. If you look, this site of contraction is not going in one direction systematically like this. It's happening in all these spots at essentially the same time. And take a look at what used to be the bolus. It's pushed in both directions. And it's broken down essentially to be smaller and smaller and smaller. And that will continue as it's pushed through the large intestines. All the time, you are absorbing water. Ideally, if you end up constipated, one of the problems that might be at hand is a water absorption issue. You're absorbing too much. Diarrhea, ending up not absorbing enough water. Some antidiarrheals, let me kill this, we're almost out of time, are going to work simply by reducing the amount of water that stays. So they'll kick up the absorption of water back into the body through the large intestines. There's a lot of pathology with the large intestine, small intestine, especially when you deal with irritable bowel, Crohn's syndrome, or Crohn's disease, things like that, which hopefully these last couple of slides might give you an idea how to dig into those if you are interested. Then when we get to the end of this whole process, when we get to the anus itself, a couple of the things that many of us feel are most important are the internal and external anal sphincter. Hopefully, most, if all of us, have fecal control. Nobody for the first part of the semester seemed to bolt from the room because you had good control through internal and external anal sphincter. On the left-hand side with the bullet points, if you look at the internal, it's blue in here, and it's internal. It's deep versus superficial with the external. The internal, it's smooth muscle. It's not skeletal muscle. So being smooth, it's involuntary. It's one of those things that you can't control. Maybe I'm speaking to some of you where you've had issues where your internal anal sphincter has been saying, hey, it's not in your control, and you really have to defecate, and you're doing everything you can to keep from defecating. That's where the external anal sphincter comes in. This, the green, more superficial around the outside, is skeletal. By being skeletal, it's under voluntary control. This is that very uncomfortable feeling that some people have experienced where you really have to get to a bathroom, really, and you can't quite make it. At least you don't think you can, but you try. What you're doing is you're using the external. So once you decide to defecate, the feces that you produce, typically the numbers that I have are in healthy stools somewhere around 75% water, 25% solids, and with those solids, we're looking at somewhere around 50% bacteria. So feces is about 50% bacteria that were picked up and dead from the large intestines. The other 50% or so happen to be fiber. So that's the breakdown. What goes in is a great omelet. What comes out is water, bacteria, and fiber. And between the going in and the going out, what we've done is we've chemically and we've mechanically broken all of that food down, and then we've absorbed it. We've taken it into the body. We've taken it into our tissues. So I hope that now you can see what I started this whole thing off with, is the fact that, yeah, just because you eat something doesn't mean that it enters your body. It can move all the way through and come out and never have moved into your tissues and never become a part of you. That is a very long look at the intestines. So let me wrap this up. At this point, I will try and put one more kind of follow-up with an overview of what we've done as Unit 4, Digestive 6 of 6. I'll see if I can get that done. Content-wise, this is where it will end. And for those of you that are watching this and checking your email, I will be getting your grades to you tomorrow. I've kind of dedicated today at doing all of my classes PowerPoints, and I've tried to push off for one last day until tomorrow, which is Friday, getting your grades to you. A number of you have said, hey, I want my grades, and I want you to get your grades. I don't want them anymore. So I'll be getting those to you tomorrow at the latest. If you have any questions, you know how we finish this up, get a hold of me.